Okay, so yes, welcome to this webinar on 3D camera solving with Mocha V3. So as Ross said, I am Martin Brennand, Product Manager of Imagineer Systems. And so yes, we're coming live from the lofty shores of Melbourne in Australia at a pleasant hour of just after midnight on Thursday. Aren't time zones fun? Today we're going to be breaking down a few shots and talk about how to track for 3D, but also the best way to solve shots and bring them into applications for use. Now, this is not going to be a shot completion webinar because 1.5 hours isn't really long enough for that. However, we will be breaking down the main elements of getting you working once you're inside your compositor or 3D application, such as setting up your 3D environment and so on. So the apps I'm going to be focusing on today, aside from Mocha, are After Effects, Nuke, and Cinema 4D. But the similar workflows will apply for applications like Smoke, Maya, and HitFilm. And we have some tutorials about the 3D workflow for those online. So I'm going to run through everything at a reasonable pace. Now, as I'm broadcasting from Australia and out to the world, there is going to be a little bit of lag, so I'm going to keep that pace reasonably slow. So if you feel I'm going too slow, that's just because we don't want to make you miss anything. There'll be plenty of time to ask questions during and after the presentation, and Ross will be answering questions as we go, so you can type away as you do it. So let's just have a quick breakdown of what we're going to go through. So we're going to have a quick planar tracking crash course. I imagine most of you are familiar with planar tracking in general, but we'll basically be doing that crash course while we're doing a solve. So you won't sort of lose any information by watching all that. Then we're going to cover the Parallax solves and just talk quickly about why we need to do different things with Parallax solves and how to line up those solves in 3D with the exported nulls. We're also going to look at orientation, and this has been a big thing recently with a great script by Matthias Moll, who created this great script called Orient World in After Effects. And I'm going to show you a manual technique in Cinema 4D as well to just make sure those nulls are where you want to play with them. We're then going to look at the pan tilt zoom solver, which is slightly different to the parallax solvers and just what you've got to look out for there. And then we'll move on to moving objects, where you can track a shot and then track moving objects within that shot to use attached nulls for other 3D objects. And we'll look briefly at locked off shots as well, to sort of a trick to solve a camera that isn't actually moving anywhere. So let's just quickly talk about why Mocha has a 3D camera solver. So before Mocha V3, we had a lot of artists who could not get 3D camera solves with standard features trackers due to a lack of trackable points. So what they would do is bring their footage into Mocha, track in features such as fake markers or a grid, and then they would go back into their 3D feature tracker and use the composited planar track insert to help solve that shot. Now, we thought rather than going through this middleman process of having to bounce between apps, it would be easier to just let people do the 3D solve in Mocha without our planar tracker. Now, the second reason is Mocha deals with motion blur and depth of field really well, so it's much easier for Mocha to solve a shot that would normally throw feature tracking off. We also handle the intrusion of foreground objects quite well, and we'll go through that in the first example. Now, when you get the final result of this export, we have this thing called planar cloud data, which is a nice way of saying we export the surface with nulls. And this means you get a lot less dense information that you have to work with, so it's easier to see where your 3D objects are going to go into the scene. And finally, it's useful for just your everyday Mocha 2D tracking. So if there's an untrackable plane shot, like say a turbulent water in a river, but you have a nearby solid plane to work with, like that bank of the river, you can track the trackable planes in the scene and then use that 3D solver to place the plane in the untrackable area. So they're the main reasons. Now, I have to sort of point out too that those coming from Adobe, obviously the camera solver is not in the Mocha AE version, that's in CS6, CS5, or CS4. So this is only available in the Mocha V3 of Mocha for After Effects and Mocha Pro. Now today I'm going to be using the Mocha 3.2 pre-release. Now this is currently in open beta. You can go to the forum at forum.imagineersystems.com Now, we really want people to test this out because the release has new support for Unicode, which means a lot for our international artists who want to use their local language in file and layer names. It also has proper mountain line support, which addresses a lot of the pesky license issues that can come up with mountain line due to interesting host ID issues. And there's also some 3D null names, which is what I'm going to show you today. So it's a handy feature that helps name all your nulls according to their layer, their position, and their accuracy. So there's many other features and fixes that I won't talk about today, as we've got some 3D to do. So that's enough rambling. Let's get into the examples. So here we are over in Mocha, and I'm just going to hide this stuff because this is my pre-baked stuff that we'll look at in a minute. And I'm just going to show you exactly what it is that I want to do today. So I'll just load up QuickTime. Now this is going to be a little bit laggy, but you'll get the general result. If QuickTime behaves itself. And QuickTime is not going to behave itself. I say, it's always when you're doing demos. Let's try that one more time. So this is going to lag a little bit on your screens. So I'm just going to drag through there and we'll see what we're doing. So we've got this guy coming through and he's running and he's ducking and there's some 3D particles exploding behind him and he runs off the shot. So what we need to do in this shot is track our walls to actually get the projection of 3D data in this scene. So here we are in the shot. I'm just going to zoom in so we can see that a little bit clearer. And I'm going to go quickly through the first parallax shot, but take you through some of the things you need to do a good planar track. So planar tracking is different from feature tracking in that it's going to be tracking texture in the shot rather than individual points. So when we get into this sort of motion blurry area, the planar track will see how that texture is moving relative to the non-blurred pixels and get a really solid result. So first of all, I'm going to just draw a shape in the scene. So I'm going to come over here to this wall and track that nice and big. Now I'm just going to make sure that when he comes past, he's not going to get in the way. And he is just a little bit here. So let's just drag that up just a little bit. Now you can see here that that is animated. So we can either do one of two things. We can leave it like that because Mocha will quite happily track with an animated spline. Or we can just come in here and delete that first keyframe to make sure that it's sitting in the same spot. So once we've got that, the next thing we usually want to do is set up our surface. Now this is very important in 2D tracking, but it's also extremely important in 3D tracking because we need to be able to see how that surface is going to be set within 3D space. So I've turned on my surface, which is this blue button up here, and I've turned on my grid, which is this pink one up here. And I'm just going to align that surface to the wall in about the approximate position that this wall is sitting on. So I'm just going to use that seam on the side of the wall here, and I can see a little bit of a vent up here that I'm also going to use to make sure that's lining up correctly. So we're just going to line that up like so. Now, once we have this shape and this surface set up, we can start our tracking. Now, it's very, very important to point out that the shape and the surface are not going to actually affect the track. Now, what I mean by that is if I move my surface around, sorry, my spline, let's just turn on the mat so we can see that, that is not going to actually affect our tracking data in any way. It is literally a search area that we use to make sure that we know where the tracking is going, but it's only a child of the tracking data. It doesn't control it. And the same goes for the surface. The surface helps represent the plane, but it is not actually the plane itself. And this will help us define both 2D data and in the case of our 3D solves, our 3D nulls when we export out to our applications. So I'll just turn off that matte now, and I'm going to come down here to my tracking information, and we'll quickly go through these. I'm not going to go through every feature, just the first few, because they're the main points we want to cover for 3D. So here we've got our input channels. The luminance is basically converting our channels to black and white and finding the best contrast through the shot. Auto channel will try and find the best channel to use, so in the R, G, or B. So in this case, with all the blue in the scene, it would probably try and find a blue within that shot to find the best contrast. Now, minimum percentage of pixels used is probably the most important one to be using. That gives you the accuracy of your track. You can see here at the moment it's set to 30, and this is a default value that it sets according to how big I've drawn the shape in the scene. So you don't have to keep it at that, and I'm not going to. I'm going to set mine to 90, because there's a lot of motion blur in this scene, and I want Mocha to use as many pixels as possible. Now, this is very important for 3D solves. You want to get the most accurate track you can, because the 3D solver relies on our 2D tracks to get a better result. So I'm also going to turn on perspective. Now, some people ask a lot of questions about the difference between perspective and shear. The main difference is that perspective is a movement not just in XY, but also in depth. So if there's an obvious turn in the scene where the pixels on this side of our surface are different to the ones over here, we want to try and use perspective because that will give us a better result. Shear is generally a warp just in X and Y. So like if a person's walking towards the camera and their clothing is moving, that is generally a kind of shear. This will also help to some degree with minor rolling shutter, but it's not meant to fix rolling shutter. It will help just a little bit. So they're the main features I want to talk about. The other ones are sort of more detailed parameters that we don't really need to cover in these tutorials, but we do have tutorials and documentation on those. So I'm just going to start tracking this one right here.
And Martin, while that's tracking, I just want to point out a couple.
That matte again.
Hey, Martin, can you hear me?
Yeah.
Oh, hey. Okay, while it's tracking, I just wanted to point out that a couple of people were asking in the chats, exactly what are you doing here? Why are you tracking first before solving? So do you want to point out just that how you're basically covering the core features of planar tracking before we really get into 3D solving?
Yeah, so the reason I'm covering this first is that the camera solver works specifically by using the planar tracker that's in the 2D module. So Mocha is known for its 2D planar tracking specifically, but we use our 2D tracking module to track elements within the scene, and then we take those layers and solve a camera from that tracking information. So when we're getting this really, really ferocious data here, it will track down really, really well, and we'll be able to lock down that information.
So Martin, if you wanted to use just the 2D data, for example, to stick a new graphic on the wall, you could just do that with the regular planar tracker, correct?
Correct. So if you've got, like, for example, this surface right here, we could just immediately go to our insert clip and say, for example, put in a logo, and then that would actually just roll in with no problems, and that would lock to our shot.
Right, but the reason you want to use the reason you want to use your 3D solver here is to actually add 3D objects and get a 3D camera out of the scene.
That's right.
Great.
So once we've done a single 2D track, we want to be able to then go ahead and track other layers in the shot. Now, for parallax solving specifically, when you're doing 2D tracking, you need to actually do two separate non-coplanar layers. Now, what I mean by that is that I don't want to just track another layer on one wall to get the solve. I need to tell Mocha there's more dimension to this scene than just this wall. So I would track either the wall over here, because this is a different plane to this wall. I would track the ground, because that is a different plane. Or I could track the very, very far distance, because over here is its own plane. And as objects get flatter, as they get towards the back of the scene, you can still track this area because there's enough detail to work with, and it's still considered to be planar. Here, I'm going to just track this wall and the ground, and then we'll talk about placement of layers. So I'm just going to turn that one off for the time being, and we'll get rid of that logo now. We've talked about that. And I'm just going to track this wall as well. So I'm just going to draw another scene here. And again, we've got a nice, easy line up here because we've got these bricks to work with. So I'm just going to line up my surface to this wall. And we can start tracking that one again. So I've turned off my cog for this one, and I'm going to name this layer because it helps to name layers. So I'm going to call this one wall R for the right wall. And up here, let's call this one wall L. So, yeah. And again, I'm going to turn on perspective, and I'm going to set my value to 90. And then we can begin tracking again. So the reason that we do this is that we need to get that extra dimension between the right wall and the left wall so that we can get that depth for the camera. Now, generally with parallax solves, both small parallax and large parallax, we need to be able to get at least 2 layers. It's helpful to have more in some situations because it just gives us some more information, but 2 is the absolute minimum. Now, what I mean by parallax is that when the camera is moving, we're getting parallax within this shot. So the difference between the foreground and the background is changing, and we're getting a sort of, parallax shift, as in the actual physical word parallax. So we have small parallax, which is a very subtle change in parallax, and large parallax, where the foreground is moving quite significantly different to the background. Now, in this case, this is a large parallax shot because we've got this very large turn happening right at the end, and this foreground area is moving quite differently to the background. Now, I'm not going to go through and show every layer because I've got this pre-done one here, but what we're going to do now is just quickly talk about the placement. Now, in the original footage, I had it shooting just above his head right here. So what I want to do is track another layer. I could use the information from this layer, but to give the solver even more accuracy, we can track another layer just above his head. In order to do this, however, we need to mask out the foreground guy so that he doesn't interfere with our layer. So I'm going to turn off these 2 now, and I'll turn off my grid. And I'm just going to do a quick mask for this guy. So from about here, it's going to be a very rough garbage mask around the top half of his body. I don't really care about the bottom half of his body because we're only worried about this top area here. And I'm not even going to track this area. I'm just going to quickly do a manual key here. So I'm just going to move my spline around. Until he's out of that wall. So let's just bring him over here, and I'm just going to cut off the in point of that layer so I don't have to see it after this point. So we can see a little bit tweaking in there, so we'll just do a quick animation here. And he ducks down here, so we'll bring that down. So we'll just make sure we've cut those points, so that's great. So I'm just going to stop it there and cut off the out point. So now in this red section, we're not going to see this layer anymore, just the area that we care about. So what I've created here is now a foreground mask, and I'm going to call it that, so foreground mask. And this does not actually come into our camera solve. It is literally just to mask out the tracking that's happening next. So I'm going to lock off that layer, and I'm just going to make it a different color so that I know what it is. So when I come back to my layers later, it's easy to define it in the shot. I'm then going to create a new layer that just takes in the detail behind him, like so. And again, I'm going to set up that surface so that it lines up. So we've got a nice, again, this nice vent here. So we'll line that up. And again, I'll turn on my grid just to make sure it's looking correct. And we can again use this nice line we've got here to make sure it's looking correct. And then very importantly, I need to drag that layer below the mask. otherwise it won't be cut out by the mat. So I'm going to call this one wall R2, and we'll just quickly look at the track mats. So here we can see, if I just make this a different color, that the track mat of the foreground mask is now cutting out the tracking information of the wall that I want to track. And this is very useful when you're having to do large obstructions in the shot. You could animate the shot instead. Like you could animate this spline around and avoid him, but this is a lot easier because it means that you can just do a very, very rough garbage mask and it will be ignored when it comes into the shot. So we'll do that so you can see how that's tracking through. So I'm not going to go through and track all that. I'm going to show you the previous example that I've already done. So I'll just delete all of these layers. And we'll have a look at our finished shot here. So we've got our foreground mask. Helps if I turn on my group layer. There we go. So we've got our foreground mask here. We've got a wall mask, which I'll go into later. This is just a standard spline that I'm going to use to block out particles later. And we've got our 4 tracks here. So I've done a ground track as well, which just follows along that separate path there.
So Martin, just to recap here, I'm seeing that you have 4 tracks for 4 different basically surfaces, and then you put a mask above the actor as he runs into the screen, so that the track below it can track through that scene. Correct?
That's right. Yeah.
Okay,
so
great.
It's only for a short section of the scene, so it will be ignored by this track when we come through.
So using that technique, whenever you're tracking something and you have foreground movement in front of it, but you don't want to track that, you would just put that above your track area.
That's right, yes. And you can do as many of these as you like. If you've got quite complicated foregrounds in front of background information you want to track, you can make many foreground masks as long as they're above the other layers that you want to track.
Great.
Okay, so we're almost ready to solve here. So we've got 4. Now this is probably overkill, but I just wanted to demonstrate the point of how you can set up different layers. But very, very importantly is to talk about the surface, and this is an extremely interesting part of the camera solver. When we actually do our solves, it's important to pay attention to the size of our surface. We could go ahead and make a very, very large surface here, and it would still solve okay, but the camera solver is looking at the planar data and has to place these nulls on the surface corners. So you get a better solve if you make this surface reasonably small. This is because the solver doesn't have to do as much projection calculation between the foreground nulls and the ones that are projecting further into the scene. So if you make your nulls a reasonably small size, like I've set up here, they will actually solve a lot better and you'll get a better solve quality. If you make them very, very large, you still will get a good placement, but the solve may take a little bit longer and the quality may not be as good. So I'm going to go over to the camera solver now and just talk about the different solvers and how we address shots like this. So I'm going to come over here to the camera solve. Now, when you do a camera solve, the first thing you need to do is select the layers you want to do the camera solve for. So I'm going to select the left wall and just hold down Shift and select all my other layers here. So I've got wall left, wall R2, wall R, and the ground. If you need to select individual layers, you can just hold down Command or Control and just hold and just select individually. But normally you would want to do a cluster like this. So we'll just select them all like so. Now, the camera solver has some very basic parameters, but they're very powerful. So we have the auto to begin with. And auto works by just running through and looking at the motion of the scene that you've tracked, and then working out what type of solve it actually is. This is very helpful if you're not really sure what your camera solve is doing, and you want Mocha to guess for you. The only downside to auto is that it's a little bit longer. It has to run through a couple of guesses to see how the track is actually moving. So if you know what the track is, it's much easier to just select the drop-down and choose for yourself. So under the camera drop-down, we have pan, tilt, zoom. which we'll cover in a few examples time. But this basically means the camera is locked off in space, and it's not got any sort of dollying going on. It's literally just a pan-tilt zoom. Small parallax is what we discussed before, so it's a very small change in parallax in the scene, and large parallax speaks for itself. And this example is a large parallax shot, so I'm going to choose that one. Once you've chosen one in the drop-down, you've got options of focal length. Now, generally it defaults to 35 to 70 millimeters because that's pretty much the default, but sometimes you don't know what it actually is. So in this case, I don't actually know the lens that's been used, so we can hedge our bets by just selecting all of them. And Mocha is pretty forgiving at trying to work out what it is. Because it still will run through all these, but it'll get the right results eventually. So this is just a refining process to help speed up the solve. And we also have zooming. There's no zooming in this shot, so I am not going to check it. So once we've done that, we can just click solve. And what it's doing now is up in this corner, is just churning away and solving for those 2D tracks. So it takes a little bit of time just to work out the various positions of all these planes, and then once it's done, we will have data that we can then export out to different applications. So we'll just let that finish.
Hey,
we're done.
Hey, Martin.
So
while that's just finishing, I'm sorry to interrupt you. A couple quick questions. Some people were asking about lensing, solving the lens, and they asked, did you solve the lens in this particular shot, or you're just going through the shot to show how the camera solve works?
So I'm basically going through, I'm only going to show the camera solves in this one. I have pre-solved the lens for this shot. We do have our lens module, and I do recommend going through the lens module tutorials that we've got on the website. So in these types of shots, you can usually get away with not too much lens solving, but obviously the options are available in the lens module over here, and we can export out to what we need, such as the camera data for After Effects, and also ST maps for Nuke. So, but in this case, I've already pre-solved the lens, so we don't need to worry about it. So here we've got a solve quality. Now 97% is very good. It can come down to about, I would suggest, 85%. If you start to get below 80, you might want to try and resolve the shot with some different layers. Generally, you'll find good quality with 80% and above, and the indicator just gives you an idea of how well it's gone. We can then export out our camera data. Now, in the camera data, we've got a few options. We've got export out to After Effects 3D motion data, which is the same thing you would be used to from our standard After Effects exports, which is just a copy to the clipboard. You will need to download the plugin for After Effects to run this data, though. So that's available on the website as well.
That's a free plugin, right?
Correct, yes. It's not licensed in any way, so if you need to get data over from another application, from another client, for example, you will be able to use this plugin without the license. We then have FBX data, and this will go out to most 3D compositors and editors, so Maya, Cinema 4D, and Smoke. And we've also got FBX data specifically for Nuke. The reason we have a separate one for Nuke is that Nuke's axis works just slightly differently, and they also run a different format to most current FBX models. So we wrote a specific one so Nuke users don't have to fiddle around with the data too much. And then finally, we've got HitFilm composite shots for HitFilm users out there, so we can bring that data straight in if necessary. So first of all, I'm going to just use After Effects 3D motion data and show you a basic shot setup using that, and then I'll show you the final result I created in After Effects. So I'm just going to copy that to the clipboard, and we'll switch over to After Effects. Okay, so here we are in After Effects. I'm just going to load up a piece of footage.
And as that's going, Martin, just want to reiterate that the camera solver is found in Mocha V3 versions, right? Not in the bundled of Adobe After Effects that comes with the Mocha AE that comes with CS6.
Correct, yes. So it's only available currently in Mocha version 3 and up. The current version that's available at the moment is Mocha AE and Mocha Pro 3.1.1, and Mocha 3.2 should be out at the end of the month. But we also encourage you guys to check out the beta, as I mentioned previously. So I'm going to load up my data here. So we've got our scene set up here inside After Effects now, and we just come up to Edit and Paste to Mocha Camera. So I'll just reiterate that you do need to grab that plugin to get this option inside the edit window. So I'm just going to paste Mocha Camera here, and boom, we get a whole bunch of nulls. So these nulls here we can see are named according to where they were in the scene. Now, this is a new feature in 3.2. Previously in 3.1.1, you would only get Mocha Null 01, Mocha Null 02, Mocha Null 03, etc. And that was kind of confusing for users. So we've made it a lot more user-friendly so that people can see what's going on in the shot. So we get all these nulls that we've made from the layers, and we also get our Mocha camera. So specifically, we're looking now at the center null here. We can see it's pushing off the wall here. And we want to use this null now to project some particles so that when he ducks, their particles explode off there. So I'm going to show a very quick example of that. I'm going to create a new solid and click OK. And then I'm going to come up to Effect. I've already got Particular up here, but under here it's Trap Code, Particular. So I'm using Trap Code Particular specifically because it has an amazing engine to work with. Very, very flexible. So the first thing we want to do is I'm going to move this wall data, wall R, up to the top of my composition just so I can work with the center null. And I'm going to press U on my keyboard to pop up that positional data. So first thing we want to do in particular, if we scrub the timeline, you can see that that particle data is sitting right in the middle of the shot. And I'm just going to make that a little bit larger so you can see where that is. So there it is. So at the moment it's just sitting in the scene and not really in the right spot. So I'm going to move that over to the center null up here. So we'll go into our effect here. I'm just going to scroll up this a little bit so we can see. Oops, 100. And we'll come into our effect, go into Particular, the emitter, and under here we've got X, Y, and position Z. So I'm just going to come down to my position, copy that, and I'm going to paste it straight into that positional value. So that's the X, Y done, and then we need to do the Z as well. So I'm going to grab the Z value and paste that in. So now when we scrub through, we'll see that particle has exploded because it's actually close to the camera. So what we want to do is just bring that size right down. So I'm going to make that 1. That's still pretty large. We'll make it about 0.1. Like so. Then once we have that, we can then make that a directional, or we can, if we go to the emitter, we can make that a directional rather than a uniform, and start sort of playing around with where that data is going. So I'm not going to go through all the information here, but I'll show you the final example of what I've set up. So here I've set up 3 separate particular hits, so for each time that he ducks. And I've set up another top level thing here where I've actually pasted in that spline data. So if I just trash this for a second, if we scrub through our timeline here, we'll see those particles come into the shot. But as they come through here, they're starting to come into this wall and don't look like they're actually sitting in the scene anymore. So what I've done is just simply grabbed my original footage, duplicated it, brought it up to the top, and then I've gone back into Mocha, And I've just linked this spline here. So this spline is just a very basic spline covering the wall. And I've linked that mask to the original wall track I did here. So I'm going to now export that out as a shape. And I'll just copy that out. So I'm going to copy that data to the clipboard. And then back over in After Effects, we can just paste mocha mask. And then that would mask out any particles that hit this wall rather than actually going behind it.
So Martin, you use Mocha and After Effects together at the same time, as if Mocha is just this utility, right?
That's right, yeah. So it's very, very easy just to switch back and forth between After Effects and Mocha, and it's also very easy to switch back between Nuke and Mocha when you're dealing with splines. For a lot of other things, you have to actually load files, but After Effects has a much easier clipboard format using ASCII information to be able to pass information back and forth quite easily. So I'm going to show exactly the same example now, and set it up inside Nuke. Nuke is slightly more complicated in the initial setup, but once you've got it, it's a lot more easy to work with. So I'm just going to switch over to Nuke now. And well, let's come in, and I'm going to start this from scratch actually, so we can actually see the whole thing from the beginning. So back over in Mocha, we go back to our camera solver and we just export camera data again. You don't need to resolve every time you export camera data. You just select the data that you need to do, and we'll just save that. I've already got that saved out though, so I will cancel that and we'll go back into Nuke. So the first thing in Nuke you need to do to set up a 3D scene is set up the actual scene. So I'm going to bring in a scene here. So scene, don't need that one. And then in that scene we need to have a camera. So I'm going to bring in a camera. And we need to have a read geo to read the FBX file. Now all of this has to be rendered out, so we also need to make a scanline renderer. And our scene goes into our scanline renderer, our camera goes into our scanline renderer, and our read geo goes into our scene. So once we have this set up, we then need to provide a background for the renderer. So I'm going to press R and load in the information. So I'm going to find my footage. And I'll just feed that into the scanline renderer. Now, once we have this scene set up, and I'll just make that fill the screen so we can see it, I'm going to now load in my camera data. So I'll double click on the camera. And underneath here, we need to read from file. Then we can go to the File menu and open our FBX file. So I'm going to go to my FBX directory, find my Nuke FBX file, and open that one. So it's going to ask me if I want to destroy the camera data, which I do. So I'm going to click Yes. And then the next thing we need to do is load the FBX data in. So we've already got our camera in place. If I go to my 3D, you'll see our camera sitting in space there. And if I scrub our timeline, you'll see that moving around. So we'll go back to the 2D window, and I'll read in the geometry next. So I'm going to double click on the read geo. And again, I'm going to open the file and choose that same FBX file. So I'm going to grab that FBX file again, open it up. Now the first thing you'll notice is nothing appears in the window, and the reason for that is that we need to set the object type from mesh to point cloud, and then everything pops up in the right spot. So we can see all of our nulls in place now, and these come up as mesh vertices. So they're actually little points in a single object that we can only select if we come up to our vertex selection mode up in the top right of the Nuke viewer. So I'm going to select vertex selection now because we're going to need that in a minute. So the way that you set up data for a Nuke vertexes is that you need to align them to the vertex points. So if we look at the 3D scene, I'll zoom out a little bit further because there they are. So we can see that 3D object in the scene, and we want to align an object to the vertex on the far wall here. So the first thing we need to do is to select that vertex. And the only way you can select that vertex is if that vertex selection option is set in the menu here. We can then bring in whatever object we need. So in this case, I'm just going to do a very quick sphere, just to drive over the point. So I've just brought in that sphere object, and we'll just zoom in there so you can see that node tree again. And this sphere now needs to actually sit where I've selected my vertex. You can see it just here in the middle of our scene right now. And the way to do that is we've got in the sphere panel this snap menu. So if we click the snap menu, you just choose the selection option that you want. In this case, I only really care about match selection position. But when you're dealing with actual orientation, you want to do the all three, or either the size, orientation, and position, or the position and orientation. And this is probably the most common one you'll want to use. But in this case, because it's a sphere, I'm just going to select match selection position. And then that will pop into place over here. So I'll just go back to my 2D view, and we can see that sitting in the view. I'm just going to change that radius to about 20. That's huge now. It's not lit at the moment, which is why it's so dark. But now that will actually move with the scene and carry through the shot. So that's the basic setup of a Nuke scene, and I'm going to show you the final example that I set up for this one. So in this particular example, I've set up a particle emitter, and I'm feeding that into the scene instead of that sphere that I orientated. So the card in this instance is locked to this vertex up here, and that's emitting particle data like the previous example I showed you in After Effects. So I'm just going to make that large so we can see, and I'll just scrub through the shot, and we've got that little particle explosion happening in the same way. Now, if I wanted to do the same spline information as before, if we actually move through this shot here, I've already got that spline set up, so I'm just going to go back to my original panel. And we do the same thing. So we feed in our rotor information. So I'll go back over to Mocha Pro, take that tracking information, export the shape data, and choose Nuke 6.2 Roto. And we can copy this to the clipboard in the same way, or save it as a Nuke script. So I'll copy that over, and then we can paste that into place. So that's the first setup I wanted to talk about, and we're going to move over to a more complicated shot now, where we have to deal with tracking shapes that are moving out of the screen. So I'm going to quit Nuke 2 because we don't need that one for the moment. I have a lot of applications open, so the less I have open, the better.
Okay, Martin, as we're going, I just thought I'd jump in here and mention a couple of the questions that people have been asking. How does Mocha's 3D tracker compare to other camera trackers? And certainly to me, I think one of the main reasons is that Mocha uses planar tracking in a different way so that we can solve out of focus and really shaky shots and shots that are obscured. Can you think about other reasons? Obviously the moving object tracker.
Yeah, so the main reason for the Mocha tracking beginning, like as I mentioned at the start, is that the Mocha tracker specifically is good at handling those shots that feature trackers cannot. So it's very useful for when there is not much feature information. So for example, if you're trying to track the leather seat of a car, for example, or the shiny surface on the side of a car, it's hard to find feature points in that actually work. But because the planar tracker can actually find large areas of texture, it actually works really well. Like in the example we've got here, this concrete doesn't actually have all that much going on, but we're still able to track a lot of the information in here even when motion blur hits it, because we're looking at the overall texture detail. So even if this went out of focus, Mocha is very, very good at finding how that texture is changing over time and still tracking the information even if tiny details are lost. And the same goes for grainy footage and noisy footage, or footage that's in like a rainstorm or things like that. Mocha is very good at ignoring extraneous information like that to get the underlying texture underneath. Now, where it would differ most from major feature trackers is that it probably doesn't have like the massive tool set that other feature trackers would have. Like, it doesn't do 3D object placement within the actual program. But we're always looking for feedback about what users want to see in the camera solver, so we'd really be interested in feedback from people who are used to using other camera trackers and actually want to see more content within the product itself. But for our purposes, the camera solver is a very, very useful tool to take existing 2D tracking data and applying it to a 3D space. So here, I want to place a sign above the door here. And we've got this very large sweep of this alley here. Now, the problem is that to get the full motion of this sweep, I've had to track areas that are going outside the scene. So if I turn the mats on here, I'm going to turn on all mats so we can see all of our mats here. So what I've had to do is, as this tracks out, you can see I've only tracked up to here. This is because if I get too far, I'm going to lose that track entirely. So I just let that drift in place after that. If we turn on our surface, we can see that sitting in place correctly. And then it just drifts. But Mocha will ignore any non-tracked information with camera solves. The very, very important thing to note is that when I've stopped a track that is going to go out of screen, I pick it up again with the next one. Now, the next part of the wall here is overlapping quite significantly the wall down here. So if we look at the blue in the timeline down here, if I move my cursor to about here, we can see there's a range of blue from the end of my cursor to where the tracking stops. If I select the next part of the wall, you can see that it overlaps quite a bit in time with the previous track. This is very, very important to do when you're dealing with tracks like this, because the camera solver needs to see overlapping information to blend in data information. So if you just stopped and started two separate tracks with no overlap, you're probably going to get a very severe bump in your shot as the solver tries to work out what happened between one section of the wall and another section. Because these are two separate layers, it has to deal with them in two separate ways. Now, some would argue that we could actually track this section of the wall and this section of the wall all in one layer, and that's what you would normally do with a 2D track. Now, the reason you don't want to do that in a 3D track solve is that the information over here is much, much further away than the information over here. And although we could do a very large track on this wall, you won't get as good results as you would with motion that's happening at the start of the scene here, and then motion that's happening further away, further deep into the scene. And we can see the same again here with the ground. So the ground, I've tracked the first section up to here, and then I've continued on from this section up here. And then finally, I want to place my sign over here, so I've just tracked another little section. This is only a subtle section here, and it doesn't overlap too much, but it's enough to make a difference. You don't have to overlap every single layer, but you have to overlap key areas to make it help. So if you do have a long wall section or a long ground section, make sure your tracking overlaps when you're doing the tracks. So I won't go ahead and solve this one. We just select all of these again and solve. And in this case, again, we're shooting from a quite high vantage point and we've got a large parallax going on. So I would solve for those same parameters. So I'm going to show you how this is set up now inside Cinema 4D. So I'm going to move over to Cinema 4D. and we just merge in our shot. So I'm going to come in here, and I've saved an FBX file out for this shot. So when you bring in an FBX, you can just click OK on all the defaults. You don't need to change any settings. It will bring in the file in the correct way. So we've got our moving camera there for the sweep. And then we have the rest of the nulls for the entire scene. So if we zoom in a little bit here. Oop, too far. We can see them all clustered there. So the way to see these easily is to use the little view camera object up here in the layer panel. And we'll start to be able to see those nulls projected in the right places. So the way to see these placed correctly is to bring in a background object. So I'm going to bring in a background here. And I'm going to apply a texture to that. So I'm going to create a new texture, new material, sorry. And I'll apply the texture to that material. Oops, wrong one. Now it's very, very important to make sure that in the animation section that Cinema 4D has interpreted the frame rate correctly. Cinema 4D does not actually interpret decimal frame rates. In this case, the file was 29.976 frame rate, and it's come in as 29. So we're going to assume for this sake that it is actually 30, and that will help. A 29 frame per second will actually slip your nulls across the background because it's a different frame rate to what the camera is. So I'm going to drag my material onto my background, and now when we look at our nulls, they will all be sitting in the right places. So if we want to orientate this scene, we need to actually group them together and sit them in plane. So you can see here that we've got the ground plane sort of sitting in the middle. And we want to actually change that up so that it sits more flat on this ground plane. So the way we do that is we find the plane that we want to work with. So I'm just going to move this back to, I'm going to open the original file that I've already done. I'm just going to merge that file in again. So the one I want to deal with is ground to center. So we can see that sitting in the plane here, and I want to align my ground plane to this null. And at the moment you can see it's sort of randomly pointing off into space. So I'm going to just rotate that null to be about pointing up, just so that it's pointing in the direction I want it to. And then I'm going to duplicate that null. So I'm just going to do Command copy and Command V, and that will paste at the top there. The second thing I want to do is grab all of my nulls and press Alt-G to group them all. And this will group all my nulls into one single null group. But I also need to add the camera. Sorry, I forgot to add the camera. Let's put that in. So we need to add the camera and the null. So I'm just going to Alt-G. And then finally, to position it correctly to the place that we want to sit it, I'm going to stick that group null under the copy of the null I've just made. The reason we need to do this in this way is so that the axis sits at the right point. So then when I pop out into my main views, I can start moving around my null to sit it in the right spot. So I'm going to drag it down in the top view. Let's just zoom out a little bit so we can see where that middle axis is. And you can see all these, if we zoom in a little bit, you can see all these nulls moving with that single group. And we can start positioning that in the right spot. And the same goes for the right view. We then want to rotate it to the right spot, so I'm just going to rotate it around so that our nulls all sit on the right plane. I'm just doing this very roughly. So now when we actually go back into our perspective view, you can actually see that our ground plane is sitting in the correct spot. Just like so. We can then start transferring objects onto it. So we can see here we've got a null point that we want to attach it to. I'm going to rotate that to the correct spot. And then we've got a sign here that I want to hook to that place. So in order to get that sign to over here, I just come up to my tools and use Arrange Objects, go to Transfer, and select that null. And then that will pop into place. You can see it's quite large at the moment. It's filling up the whole screen. So I'm just going to come back to Sign, go to my coordinates, and scale that down a bit. I'm going to make that about 0.05. Still quite large. Let's bring it down to about 0.05. That's about right. We now need to bring that down a little bit further. That's a bit better. And then we can start rotating that into place. So we can set that in the scene where it needs to be. And then when we scrub through the shot, it will be sitting in the right spot. So I'll very quickly go through that in After Effects. That's, of course, when my laptop decides to lock up. There we go. Now, in After Effects, it's actually a lot quicker. We can just go collect our ground null, which you can see is actually sitting about in the right spot. And then we can use a great script by Matthias Moll called Orient World. You just select the null that you want to use, and you click Apply. And it immediately orients the entire world to that point. It's much, much quicker than using the same method that we showed in Cinema 4D. And we can see that works by if I just create a new layer, a new solid, click OK, make that 3D, and scale it down a little bit. We can actually see that it immediately sits on that point. Normally, if you would create a solid and it was not in the right spot, it would be out into infinity. So that sets it immediately at the ground zero point in the shot. So it's a very, very quick and efficient method of using that script. And Matthias Moll has a great tutorial on how to use that script inside After Effects. So now we're going to quickly look at pan tilt zoom, because pan tilt zoom is just a little bit different to how parallax solves work. Pan tilt zoom really only needs one single layer to work. If we move through this scene, you can see that I've only tracked a single plane, and you can also see that I've not actually cared too much about where I've tracked it. I could have just tracked down here at this building, but I'm tracking the whole area, including the sky, which is actually a separate plane. The reason I'm tracking like this is that I'm tracking the camera plane, not individual planes, because the pan-tilt zoom is not looking for any parallax. So we can just grab a whole big area to work with in one individual shot. So here, I'm just going to use that one plane, go to my pan-tilt zoom. I'm going to check my zooming, because there's a slight zoom on this lens, and I'm just going to click solve. You can then export this out very quickly. Now the difference is that when you actually export out a pan-tilt zoom, you are not going to get the same information that you would normally get in a parallax. Like, things are not going to be lined up with individual scene points. What you're going to get instead is this. Let's have a look at it. You're going to get an individual section that just sits in front of the camera. So we've got our camera right here, and it's just looking into the plane, and if we just tilt that scene around a little bit, you can see it sitting in about the place that we were looking in Mocha. But they're not actually doing anything, like they're completely flat against that plane. This is because we've only tracked the camera plane. We've not tracked anything else in the scene. So when this tilts, it actually gives you a little bit more freedom to move things in the shot, but placement's going to be a little bit harder. So if we look at the original shot, it's very, very easy to set something in. I've just stuck in a video copilot element shot here of some 3D bulbs floating in space. But the depth is actually there. If I just play around with the offset quickly, we can see how that is moving around. And if I go back into 3D space, we can see that that is scaling into depth quite well. But we've only got this one camera plane to work with. So even though it's efficient, it's a little bit less flexible than the parallax solving.
So Martin, the camera solver there for a pan tilt zoom, that might be good just for like a maybe a background plate set extension or something, but only if the camera is locked to a tripod, correct?
That's right, yes. Pan tilt zoom must be locked down. I mean, the camera solver will generally tell you if it is a pan tilt zoom shot or not, because it will see movement outside of a normal locked pan. But you can just play around with those settings and it will give you the correct results. So generally, pan tilt zooms are really, really good for just when you need to insert something quickly into a shot. And I'm going to show you another example in a second of the moving objects. But it's still very effective, as you can see here, being able to just lock down simple 3D placement in a shot where you don't rely too much on locked down individual areas. So finally, I'm going to go through a shot using Cinema 4D. So I'm just going to quit out of After Effects just to give myself a little bit more freedom. And I'm going to talk about moving moving objects and locked off shots. So I'm going to go into this one. Okay, so I'm just going to hide off these guys for a sec, because I'm going to talk about quickly the locked off shot area. So I'm going to close and hide this. So this shot here, we've just got a guy working on a computer. You may notice it's the same guy that was running before and looking up at the sky. So even though this shot is locked off, we can still get information out of our shot. And the way we do that is with a little trick. What we do is we just grab somewhere in the background and we just track it as normal. Now, because this is a locked off shot, the camera is not going to move. So I'm going to turn on my perspective. I'm going to start tracking. And once we've got a fair little way in, I'm actually going to stop it and immediately go to my dope sheet, come down to the track section, and I'm just going to copy and paste the rest of those keys. So it's a little bit of a cheat.
Oh, you're tricking Mocha here, huh?
That's right, yeah. So basically what you do is you just give it false information. Even though it's correct information, you're still sort of giving it a bit of dummy data, and that will give you the correct results when you actually do the camera solve. We can then go ahead, once we've done our locked off shot, we can go ahead and track the moving bits that we're interested in. So I'm just going to call this one lock track. And I'm just going to hide that one for now. And then we're going to track the side of his face. So we'll just do a quick track on the side here. So we've got some nice planes of the face here. When we're tracking faces, we always want to look for the planes, like they're little low polygon models. So I'm just going to work with a little bit of his eyebrow here, some of his beard, and we'll lock that in there. And yeah, that'll probably do. And I'm going to use perspective here because he's turning his head. And we'll turn on our surface again. And I'm just going to align it on an angle of the way his face is pointing in the scene. So just like so. And we'll start tracking that one. So I've got started at the end of the scene, so I'm going to start tracking backwards. Now, just before I do that, I will stop and turn off my tracking cog for the original layer. And we'll keep on tracking. So what we're doing here is, instead of getting the static areas of the shot relative to the camera, we're getting the moving objects relative to the camera. Now, the way we do this is that, first of all, we have to solve the static shot. We still have to tell Mocha there's a camera sitting in this scene. So we need to solve those static areas before we solve moving areas. Because if we try and solve moving areas first, the solver will assume that you're actually solving with static areas and you won't get the camera that you're after. So we'll just track that, like so.
So Martin, the camera solver module will use what you select, the surfaces that you select for solving, correct?
That's right, yes. So in this particular instance, and we'll go with the ones I've already done. So I select my background first, so I'll turn on these layers again so we can see them. So we've got our matte here, and what I'm going to do is just come over to my camera solver, and because this is a locked off shot, we treat it as a pan tilt zoom, but in my case I'm going to use auto because that will just let it try and solve it for itself. So I'm just going to click solve, and we get 100%. The reason we usually get 100% is because nothing is happening whatsoever, because we've given it that dummy data, but it's still given us a camera solve to work with the rest of the information. So once we've done the camera solve, we then select the object that's moving. And here you can see I've localized this surface to an area I want to put in my 3D model. And then we export the data from that. So we don't have to resolve for our moving layer. We only have to solve for the static areas in the shot. But we specifically export the moving bits second. So I'm going to come down to FBX and I'll save that out. Now I've already saved it out, so I won't bother doing that. And we'll move back over to Cinema 4D. So I'm just going to close this file. No, thank you. And we'll close up this one. And I'm going to now merge in that FBX file. So I'll go back to my original place and we'll find that. Let's go to name so we can find it. There we go. Turn head and open that file. So again, here we use the same thing. I'm going to turn on the camera node to look through that shot, and we can see we've got our positional data, we've got the static background, and we've got the moving face. So we can see movement data on those nulls now. And I'm going to just merge in the rest of the background. So I'm going to create a material. And again, find that shot that I just did. Thank you. And I'll go to my animation section just to make sure it's doing correctly. And again, it hasn't. This is a 24 frame shot. Very, very important to check this. Otherwise, your nulls will always drift if you're using a floating point frame rate. And then we'll create our background. Dump that on. So we can see here we've got our nulls sitting in place and they're moving through that scene correctly. So I want to use the center null here, and I'm going to bring in a new object. So I'm going to merge in the eyepiece that I made. So let's just call this eyepiece. And I'm going to turn off the camera node so I can actually find, so we can see here this eyepiece, sort of going for a semi-Deus Ex kind of look. And I'm going to actually just shrink that down a little bit. So let's go back into our camera view. And I'll just make that 0.1 for the time being so we can actually see what we're doing. Maybe a bit less, 0, 1, 0. Okay, that's out of the way. And I again want to do the same thing. So I want to transfer it to this central point. So I'm going to come up to my tools, so arrange objects, transfer, and just select that middle point, if it will find it. Come on. Let's try it in this view. There we go. And we'll go back to that camera view. So now we've got a tiny, tiny little 3D model there. Now, it's only sitting in place at the moment, so we need to actually parent the null to that point. So I'm going to bring my eyepiece down to that center null. So now it's sitting under that null. And then it's just a matter of actually scaling it up and rotating it. So I'm going to make it about 3, 3, and 3 for all the dimensions in scale. And we can just rotate that around. So I'm going to rotate that to the side of his face, rotate it up. Probably need to reposition it a little bit, like so. And then when we scrub to the scene, oops, helps if I don't rotate the null. I was rotating the null, not the model, sorry that. So we'll rotate that around, move that in place. So now when we scrub through, it will be sitting in the right spot. We just need to move that down just a little bit. So that will actually float in space correctly sitting on the side of his head. So they were the main points I wanted to cover today. So I'm just going to quickly go back to our keynote and just show you the quick internet contact points that we've got. So you can obviously get the trials from imagineersystems.com. If you go to the forums, you can go to that beta that I talked about. So I'll come back to the Mocha beta pre-release. If you want to test out the public beta, just go to the forum and look for the Mocha public beta section, and you can download that pre-release just there. You can also check out the rest of the tutorials on vimeo.com and YouTube, and also on the main website. And you can go to our Twitter and Facebooks. I've got hashtag Mocha Tips there because every day we do a daily Mocha tip, and if you've got any suggestions for Mocha Tips, feel free to contact us. So I'll just pass it back over to Ross, and we'll answer any more questions.
All right, great, Martin. Thanks so much for that very in-depth and clear presentation of Mocha's 3D camera solver. I think that in the past, a lot of our customers have been asking us for more detail on how to use this powerful module. So it really has brought a lot of insight to a lot of the people who are viewing it. At this point, what I'm going to do is spend the next couple of minutes going over some of the questions that weren't answering, and I'll pose the questions to Martin, and he can try to answer them. I am going to point out a couple things. We did record the webinar, and we will have this posted online sometime tomorrow, and we will be sending out a link to the online video if you want to follow along again, and I believe we'll also try to post some of this footage as well if any of you would like to actually try to test out any of these features with this footage. We're also going to be... Go ahead, Martin.
Also, sorry to interrupt you.
Yeah.
If we're also interested, if you're interested in any more sort of in-depth tutorials on things I covered, I'm quite happy to actually create a focused tutorial on each section and actually do more finished shots, so you can see a more sort of tracking to completion sort of tutorial. So if you want to see those, let us know.
Yeah, absolutely. I think from some of the feedback, we saw some people who want more specific Nuke or more specific Cinema 4D tips. So I think that could be very useful. I'd also like to point out that we're going to be offering a free seat of Mocha Pro version 3 as a door prize. So we're going to be pulling a name out of a hat later today, and we will contact the winner direct. So a couple questions, Martin, for you. First, jumping back a little bit, when you first started the first example, just a couple questions. People had questions about the percentage of your tracker, basically
Sure.
in the tracking tab, and maybe you could just kind of, some people asked is this a random value? Why are you cranking up to 90 in this
Sure.
particular version?
Yeah, so the way the mocha tracker works is that it will try and optimize the best it can. So here we've got a HD shot. If I draw a very large shape in my shot, you'll see that that value is about 20%. If I draw a very small value, so just a very tiny shape, you'll see that value goes up to 90. This is a little default optimization that Mocha does to make the tracking go faster. But you need to pay attention to it because if you don't have a very solid piece of tracking information, you want to make that value a lot larger. If you've got a really big scene, say like a 5K shot or higher, because we're getting that way, you may want to ramp that value down if you've got good contrast in the scene. So if I just trash these two layers, for example, like in this shot, we could probably get away with less. Like I've got it set at 90, but we've got good texture detail in the face here with the eyebrow and the side of the beard here. So we can probably do about sort of a 70 or a 50% pixels. But what it's looking for is all of the information inside this shape here. So it will try and reduce the amount of information it has to track by this value. So it's really just an optimization. But I tend to, by default, regardless of what I'm doing, try and at least do 90 to keep good, accurate solves.
Okay, great. That's a good explanation. And to summarize, I mean, cranking that up is going to potentially give you a better track, but slow down your computer.
That's right, yes. It's going to be a much slower process if you've got a large shot to work with. And it just really depends on the type of track that you're doing. So, and it's very, very important to get a good accuracy for both the 3D camera solver and modules like the remove tool, because the remove tool also relies on very accurate tracking information.
Right. I think that so many users are so used to jumping into Mocha, drawing a shape, and just hitting track, and usually getting very, very good results, that sometimes they overlook that some of these options in the track tab can improve the results even more.
Well, that's right. So if you have a problem with your track slipping, the first place I would look is minimum percentage of pixels used, because quite often that is the culprit. Like, especially if you're dealing with a low contrast scene, like sort of fuzzy clouds and things like that. Fuzzy clouds sometimes will, if you're drawing a large shape to get the whole cloud area, and then there's a little bit of motion blur, upping those minimum percentage of pixels may grab more of the texture detail and you'll get a better result.
Sure, sure. And along these lines, as we're talking about these tabs, some more questions came up about the lens module and whether, sort of discussing what workflow would you use if you had a shot that had some noticeable lens distortion. Would you correct that shot first and render an undistorted pass, or, what workflow would you suggest?
So you can do that a number of ways, specifically for, because we only export out lens data for, say, for example, After Effects and Nuke, but we can also render them out flat. So the way you would generally work is that you would solve the lens for the shot, and then if you're going to be exporting out data specifically, so warp data for After Effects or the STMap data for Nuke or, say, Fusion, you could still go ahead and track and solve your scene inside Mocha as normal once you've solved the lens. If you're working with something else, say, for example, you're working with Cinema 4D or a 3D application, what you would want to do is render out the lens correction first and then retrack that scene by importing the rendered result back into Mocha, because we won't be able to apply that same warp data that we have inside the lens tool from export lens data. So we have these Mocha lens and distortion map data that can be used in some applications, and we can just go ahead and track and solve as normal. But for other applications, you'll want to render out the undistorted result and then start a new project with that rendered result.
Okay, that makes some clear explanation, I believe. And again, now we created this a lens plugin for After Effects that ships free with Mocha AE and Mocha Pro.
That's right, and that's the same with the camera solve plugin and the lens plugin. So they are all free plugins available on the website. So again, if you're working with clients that don't have Mocha, they can download that plugin and you can send them the data, or vice versa and things like that. So it's a very easy thing to just download, and you don't need to license it.
Right. A couple people are asking about the specs of your computer, actually, just because obviously there's a lag due to the webinar, and but people want to get an idea of how fast is your computer running and what we recommend.
So in general, like, Mocha will run on pretty much everything. I'm doing a fairly heavy thing here. I've got Nuke, Cinema 4D, After Effects, and Mocha all open at the same time using HD shots. So my lagginess is a little bit, but if you're just running with Mocha and another compositor, like, it actually runs pretty well on this machine. This is a 2010 generation Intel MacBook Pro. So it's a fairly solid machine. It's definitely not a current machine. But it handles, about up to 2K pretty well. If I start using 4K files and things like that, it's not so great. But Red is okay because we now support Red in version 3.1, and we can adjust the proxies with Red files so that you can track at a lower resolution and then solve for the higher resolution. So you can do different workflows like that. So if you're running on a not as fast machine, like I've got 8 gigs of RAM in this machine, and that's plenty. But 4 gigs is also fine. And so if you haven't got the grunt in your machine, you can just use our proxy modes. We've got full, half, and quarter. Or you can even import your own proxies and then just upscale before you do the camera solve. So in general, it's quite easy to adjust the size and the content of your footage before you export out information.
Right, and Mocha does not require a beefy GPU video card, is that correct?
That's right, yeah. You only really need CPU power. The GPU does help if you want to do things like rendering motion blur, because we do have GPU acceleration for all of our spline and matte drawing. So all of our grids, our splines, and all those things, they can be GPU accelerated, but it's not absolutely necessary. The performance of the footage and the actual tools, like the camera solver and the remove tool, are all done through the CPU.
Okay, great. And take this step back. You showed how you could use the 2D tracking first, then multi-select your 2D tracking surfaces, and then go into the camera solve. And someone had a good question, which is, how does Adjust Track fit into this feature? And for those who don't know, Adjust Track is a different tab to solve for track drift.
Okay, so I'm just going to load up that previous file so we can look at it. So when you do Adjust Track specifically for camera solving, or even just 2D tracking, you only want to do one at a time. So if I just turn on my surface here and we go over to the Adjust Track module, the Adjust Track module will pop up these little corners. I'm just going to zoom in a little bit because that might be hard to see on some people's screens. So when we go into Adjust Track, we get these tiny little corners in the shot here. So the way these work is we set a master key, and then when we go through the shot, we get these little corner zoom functions up in the top left here. And this will tell us whether or not the corner that we're working with, in this case the bottom corner from these corner controls down here, it will tell you whether or not there's been any drift going through the shot. So this shot is actually pretty sturdy, but if I wanted to adjust it, what I would do is just do a little nudge up and down to nudge those corners into place to adjust that tracking data, or I can come in here and actually physically move stuff around. So it's quite easy to do adjustments with that surface. So if you see any drift or jitter in your surface after you've done your track, you can come into the Adjust Track module and then just quickly adjust your surface once you're done.
And so
once you've done that,
go ahead, Martin.
Go on, Russ.
Oh, I was going to ask you what's the next step, but you beat me to it.
Okay, so once you've done that, you can just literally go back to your camera solver and solve as normal. Like, there's no other step you need to do. It's just a straight camera solve after that. The Adjust Track module is essentially putting a layer of animation above your tracking information and then it will collapse that information down when you go and do the camera solve. So it's a sort of transparent from the tracking process to the adjust track process to the camera solve. There's no other buttons you need to check in that instance. The only time that you need to use another button when you've done adjust track is when you're linking other splines. So for example, I just adjusted this wall here, and when I tracked this wall, I also made this spline to block out those particles, if people remember that from before. When I link to that track, underneath my link to track down here in the layer properties, if I've adjusted the track, I need to check the link to adjusted track. But that's only for roto. You don't need to do this for camera solving. It's just to handle the adjusted tracking information for roto data.
Great. So that's
camera solving, you just select as normal.
So camera solve, when you go into the camera solve module, if you've adjusted the track, it will automatically use that adjusted track.
Exactly.
Okay, perfect. And again, just to recap that little workflow, the adjust track module, it's really used to compensate for tracks that are not perfect, that are drifting, or maybe you want to use these tools to visually look at an offset track with those corner points. And so for every surface track that you have that you're going to use for a camera solve would have to be adjust tracked on their own if you needed to.
That's right, yeah. You wouldn't select every layer and adjust them all at once. And kind of point out, I just love looking at this frame because, like, even though I've been working for Mocha for over 4 years now, like the fact that it can still track information like this just blows my mind.
Yeah, I mean, I think that's one of the interesting things. I mean, hopefully everyone here who's viewing the webinar knows how powerful Mocha can be for tracking through really difficult motion blurs. And a lot of people have asked, you know, well, how does Mocha's camera solver compare with other 3D trackers? And I think looking at one of those frames is really the key here, is that we're using the planar tracker to solve the camera solve, to solve 3D cameras. So it's taking all the power of the planar tracker and then using that to solve camera data. A couple more questions. We're almost running out of time. Let's see. Well, someone asked, do you need to retrack after you do the adjust track tab? And no, you don't. Again, that workflow would be you track your surface. If you wanted to adjust the track, then go ahead and use the adjust track module. And then if you are doing a 3D solve, you use the 3D solve. So you would not have to retrack at all.
I would add in too that if you're doing a lot of adjustments in the adjust track module, you may want to try and retrack, because the adjust track module is really only to correct like little problems with your track, like a drift that's happened and then it's gone ahead and tracked fine. If you're sort of adjusting on every single frame, you probably want to go back and try a retrack or even do a manual track, because you're creating more work for yourself by doing that.
Now that's a good point. So perhaps if you're seeing a lot of drift on a track, rather than going and trying to fix it on a adjust track, a better methodology might be to actually maybe try to retrack, or try to adjust your track parameters, maybe adjust your shape of what you're tracking, rather than try to fight it in the adjust track module. Okay, let's see. Which version of Mocha comes with After Effects CS6 bundle? The version of Mocha that ships with Adobe After Effects 6 is called Mocha AE CS6. You can find on our website, I don't know, Martin, if you have the bandwidth to open up our website and just show the quick link to the Compare Products page there on our website, but we do have and if not, you'll find that right on their main site, which is just Compare Products. It will show you the features that are found in Mocha AE v3, how that compares to the bundled version with Adobe, and to Mocha Pro as well. Let me see.
Just pull up the Compare Products.
Okay, so you can see there is the Compare Products chart. We have not added a new product that we just started shipping, which is actually a partner product called SliceX, which is a Roto plugin for Final Cut Pro X users. A couple users had some questions about this new product, but you can see here we have Mocha Pro version 3.1, we have Mocha AE v3.1. These are both products that you can upgrade to from the bundled After Effects version, which you can see there, Mocha AE CS6. So Mocha AE CS6 that ships with After Effects, it's really just a 2D tracking and rotoscoping utility, and then you could upgrade that to Mocha AE 3.1 or soon to be 3.2 for some more advanced features for roto, for the 3D camera solve module, for the lens module. And then if you wanted to upgrade to Mocha Pro is pretty much what supports almost every product on the market now in the compositing market.
Pretty much everything, yeah.
Yeah. I mean, in fact, another question that just popped up was, can we use this to export to Ion Fusion? And yes, we do export both 2D and roto data to Fusion. I know we've been talking to them about their FBX support. So currently you can import an FBX into Fusion, but I think we might be off on a version. I think that Fusion is still supporting an older version of FBX, but we definitely have a great relationship with the team at Ion Fusion and are looking to improve the workflow between Mocha products and Fusion. And I think at this point, guys, it is past our time. So I'm going to say thank you very much, Martin. You did an excellent job. I'm also going to ask anyone who's still on the webinar to please take the survey as you exit. And if you have any additional feedback that you'd like to send to us, you can just email mocha@imagineyoursystems.com or just use our support forms. Of course, we have the Imagine Your Mocha forum online, which is linked right off our website. And to stay up to date with all of our latest news, we really encourage you to join our Facebook page. We also use Twitter, Vimeo, YouTube. So pretty much we're trying to get our information to you guys as quickly and efficiently as possible. So thank you again from Ross Shane at Imagine Your Systems.
And thank you from Martin Brennand at Imagine Your Systems. I hope you guys have a good day, whether you are sleeping or going out to work now.